Hi, my name is Kathy. I'm going to be walking through a tricky example of method of characteristics, which I believe was on a homework at some point or something of that nature. Method of characteristics is actually pretty simple, but this one was just a little bit complicated, which you'll see as I go through it. So it's kind of just an interesting example to look at and probably have a good grasp on. So here we have the question, u sub t plus x, u sub x plus u is equal to 3x, with the initial condition e to the negative x squared. So we know that the derivative of u with respect to t is equal to the partial derivative with respect to t plus the partial derivative with respect to x times dx dt by chain rule, since we know that u is in terms of x, xt comma t. So matching that up to our question, we see that du dt is equal to 3x minus u, and dx dt is equal to x. So as you can see here already, it's a little bit complicated because since x is also in terms of t, if we look at the first equation, du dt, we see that it's not purely in terms of u, because we have the x term there. So that's going to provide a little bit of complication when we're solving for the characteristics. So basically we are going to solve for that dx equation first. So we have dx divided by x is equal to dt. We take the integral of that and we get the natural log of x is equal to t plus c. So we get that x equals c e to the t. And since at t equals 0, x equals c, we can say that x equals x naught e to the t. And that concept of x naught can be a little bit confusing, but basically it just means that at t equals 0, that's what x is equal to. And it's just a little bit of a simpler way of writing it out. Now, since du dt contains an x term, like I said previously, we can't do the integral directly, so instead what we do is we plug in our characteristic for x, and we find that du dt is equal to 3x naught e to the t minus u. And now, this is an inhomogeneous ordinary differential equation. So that means we're going to have a particular solution and a homogeneous solution. So yeah, like I said before, u is going to be equal to a homogeneous solution and a particular solution. So let's solve for the homogeneous solution first, which means that we just disregard the right side over here. We just say du dt plus u is equal to 0. This is a pretty simple equation, and we get that the homogeneous solution is c1 e to the negative t. And now for the particular solution, we're going to guess the ansatz that the particular solution is equal to c2 e to the t. So we plug that into our equation, and we find that c2 is equal to 3 halves x naught, which means that the particular solution is equal to 3 halves x naught e to the t. So just to reiterate, our homogeneous solution is c1 e to the negative t, and our particular is 3 halves x naught e to the t. So we have that our full solution for u is c1 e to the negative t plus 3 halves x naught e to the t. Now we have to apply the initial condition, which is that u of x comma t equals 0 is equal to e to the negative x squared. So since x is equal to x naught at t equals 0, we can just say u of x comma t equals 0 is equal to u of x naught, which is equal to e to the negative x naught squared. So this is just kind of a notation thing, but it should be intuitive since x is equal to x naught at t equals 0. So now we're going to plug this into our solution for u. So e to the negative x naught squared is equal to u of x naught, which is equal to c1 plus 3 halves x naught, which we should be able to see from this equation here, because we're plugging in for t equals 0, which yields this right here. So now we solve for c1, and we can plug that back into our equation for u, and we get this kind of messy thing, which is e to the negative x naught squared minus 3 halves x naught times e to the negative t plus 3 halves x naught e to the t. And now for the final step, which is sometimes what people tend to forget is that we have to plug in the equation for x naught so that our final equation is in terms of x and t, not x naught and t. So x naught is equal to x e to the negative t, which is something that we found way in the beginning when we solved for the characteristic for x. So we get our final answer, which is u of x comma t is equal to e to the negative x e to the negative t squared minus 3 halves x e to the negative t, that whole thing times e to the negative t, and then plus 3 halves x. And that's the final answer. So just a reminder, this is basically combining advection with ordinary differential equations. And yeah, hopefully this was helpful. Thanks for watching.